Okay, this is the exam 5 in-class review for Math 1325. First problem is from 15.1. We could separate all these problems if we wanted to. The only reason I might want to is because I noticed there's a denominator there and a denominator there. This is not necessary step, but I'm going to go ahead and do it anyways, just so I don't lose anyone. So I'm going to separate it all and say this is the integral of 6x squared plus the integral of x over 3 plus the integral of 4 over x cubed plus the integral of 5 plus the integral of 9 square root of x. And the only reason I did that is so you can clearly see I can pull out constants now. This first one I can pull a 6 out. The next one I can pull a 1/3 out. This one I can pull a 4 out, and I'm going to go ahead and take the x cubed up to the top and make it x to the negative 3. So remember, if you have a number on bottom, you have to pull it out. If you have an x on the bottom, you can pull it up. On this one, I'm going to pull the 5 out. And on this one, I'll pull the 9 out. I'm going to rewrite this as x to the 1/2. So then I'm going to integrate. I'll have 6x to the 2 plus 1, which is 3, divided by 3, plus 1/3 x squared divided by 2, plus 4x to the negative 2, if I add 1 to that, divided by negative 2, plus 5x to the 1 divided by 1, plus 9x to the 3/2 divided by 3/2, plus c. And then I'm just going to simplify this. So I get 2x cubed plus, dividing by 2 is the same thing as multiplying by 1/2. So that'd be 1/2 times 1/3, which is 1/6 x squared, minus 2, I'm going to put this x back on the bottom there, plus 5x. 9 divided by 3/2. I'll come over here. That's the same thing as saying 2/3 times 9. So 3 will cancel into that 3 times. So that's 2 times 3, which is 6, plus c. The 15.1 problem. On the next one, I'm going to also put in the extra step of separating it, just in case. It might be a step you skip, but don't want to lose anyone. So I'm going to have the integral of 4 dx minus the integral of 1 over x cubed dx plus the integral of 4 over x dx plus the integral of 5e to the x dx. Then I could pull my constants out. So I'll have 4 integral of dx minus, there's no constant to pull out here, but I can take the x cubed up to the top and make it x to the negative 3, plus, pull the 4 out, leaves me with 1 over x dx, plus I can pull the 5 out. Again, these two steps aren't necessary. I'm just showing you what's going through my head here. So integrating this, I would have 4x to the 1 divided by 1 minus x to the negative 3 plus 1 is negative 2 divided by negative 2 plus 4. The integral of 1 over x is a special integral. It is the natural log of the absolute value of x plus 5. Integral of e to the x is e to the x plus c. I guess really the only thing I could do differently, I went in and boxed it. The only thing I could really do differently on that one is on the second term, I could have taken that, made it a plus because I have a negative and a negative, and taken that to the bottom. So 2x squared. So I'll go ahead and write it again down here. So that would really be my simplified answer. to get rid of all my negative exponents. Another 15.1 question says find the cost function if the marginal cost, which is the derivative of the cost, is given to us. So I am going to find the cost function by taking the antiderivative of the derivative. So I'm taking the antiderivative of 12x plus 8e to the 4x with respect to x. I'm not going to separate this one because there's no denominators to really bother us. So the integral of 12x would become 12x squared divided by 2 plus 8. The integral of e to the 4x would be 1/4 e to the 4x plus our constant. Since we already have a c in this problem, I'm going to use k for our constant. And so right now we have our cost function is equal to 6x squared plus 2e to the 4x plus the constant. But we're told that the fixed costs are $238. So that means when x is 0, the cost is 238. I'm going to put that point in. Six times 0 is just 0. E to the 0 is 1, so this is 2 times 1. And then I would subtract the 2 to the other side, and I would get 236 would equal my constant. So my cost function is going to be 6x squared plus 2e to the 4x plus my constant, which is 236 for that. Okay. I have an e in this, and it's raised to a bunch of junk. So I'm going to remind you, if we just have the integral of e to the x, the answer is e to the x. If we have an integral of e to some number times x, then the answer is e to 1 over that number. I'm sorry, backing up on that one. The answer is 1 over that number, e to that number times x. But if we have anything other than x to the 1, then it's considered junk. And so this exponent right here is our junk. So that's going to be our u. So I'm going to let u equal 5x to the 4th plus 2x squared plus 3. And I'm going to go ahead and replace that part with e to the u. I'm not pulling any numbers out of this, but I cannot pull a 5 out because 5 is only multiplied to the first term, not the second term. So I can't pull any numbers out. So that means I still need to replace 5x cubed plus x dx. So taking the derivative of u, I get 1 du equals 20x to the 3rd plus 4x dx. So what I want is 5x cubed plus x. What I have is 20x cubed plus 4x. So I need to divide that 4 from both sides. Or I could say multiply both sides by 1/4. So 1/4 du would be 5x cubed plus x dx, which is exactly what I needed. So I'll substitute in its place the 1/4 du. I've replaced all my x terms with u terms. So now I'm going to pull the 1/4 outside the integrand sign. And I can integrate. The integral of e to the u is e to the u plus c. So all I have left to do is put my u value back in. So e to the 5x to the 4 plus 2x squared plus 3 plus c. Don't forget, you can pause this video anytime you need to if I'm going too fast. Number 5, we have a denominator that is the square root of something, which is the same as it all raised to the half power. I'm going to separate this. I'm going to make this 1 over, instead of the square root, I'm going to write all this to the half power, times, on the top, I'm going to have the 8x to the 5th minus 7x squared. So I'm just separating my numerator denominator. Choosing my u, it's going to be all the stuff to the half power. So I can replace this part right here with the integral of 1 over u to the half. I still need to replace 8x to the 5th minus 7x squared. So I'm going to take the derivative of my u term, and I get 1 du equals 24x to the 5th minus 21x squared dx. So this is what I have. This is what I need. I need 8 and 7, not 24 and 21. So if I divide both sides by a 3, or multiply both sides by 1/3, then I will get exactly what I need. And we will be able to substitute in 1/3 du. So on my next step, I'm going to pull the 1/3 out, and I'll bring that u up to the top and make it u to the negative half. And here I would integrate. I'm going to have 1/3 u, negative half plus 1 would be positive half, divided by positive half, plus c. Dividing by half is the same thing as multiplying by 2. So I have 2/3 u to the half plus c, and I need to put my u back in. There's my answer. So number 6, picking my u, it's going to be the stuff raised to the second power. So I'm going to have 2x to the 4th plus 3x squared. And that takes care of the denominator part. So I can go ahead and say 1 over u squared. I still need to replace 40x cubed plus 30x. So I'm going to take the derivative of u. I get 1 du equals 8x cubed plus 6x dx. What I need it to be is 40x cubed plus 30x. So I need it to be exactly 5 times what it already is. So I'll multiply both sides by 5. And now I have an exact substitute. In its place, I will put the 5 du. Then on the next step, I'll pull my 5 out. I can take that u squared up to the top and make it u to the negative 2. And now I'm going to integrate. So I'll get 5u to the negative 1 divided by negative 1 plus c. That's negative 5 over u plus c, which is negative 5 over 2x to the 4th plus 3x squared plus c.